Hi guys, it's one and only favorite chemistry teacher. So here they gave us 2,5 diethyl hexane. So they want us to draw basically the structural formula. So since it's hexane, simply means to say it must have 6 carbon atoms, right? So that will be the first one, second one, third one, fourth one, fifth one, as well as the sixth one. And then you always make sure that you number the longest continuous carbon chain. So that will be 1, 2, 3, 4, 5, 6, right? So we are having what we call an ethyl group. So it's very important that you must know the difference between a methyl group as well as as well as an ethyl group. So they're saying 2,5 diethyl. So it means to say on the second carbon atom, we are going to have an ethyl group, right? So in the second carbon atom, we're going to have an ethyl group, which is, we know that an ethyl group is CH2, CH3. So that will be CH2 as well as CH3. So that is our first ethyl group range. So we draw it like that. So that is the ethyl group. And then also on carbon number 5, we're also having another ethyl group. So we draw another ethyl group. Right. Don't forget that the ethyl group is CH2, CH3. Then you add, or you rather write the number of carbon atoms that are appearing on that organic compound. Then we all know that each and every carbon should have at least a hydrogen attached to it, right? Then now we're up. So since it's 2,5 diethyl, so you write the hydrogens that are just missing there, closer to all those carbon atoms. So the red parts, they basically represent what we call an ethyl group. So don't forget that this represents an ethyl group. Ethyl group as well as this one represent an ethyl group. So this will be basically 2,5 diethyl hexane, right? And then let's continue. So here they want us to draw the structural formula of 4-ethyl 2,3 dimethyl octane. So since it's an octane, it simply means to say it's an alkene with 8 carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8. So that is an alkene with 8 carbon atoms because it's octane. So an alkene that has 8 carbon atoms, we call it octane. So we're gonna now make sure that we number. So that will be 1, 2, 3, 4, 5, 6, 7, 8. So it means to say this alkene it must have 8 carbon atoms because an alkene that has 8 carbon atoms, as I've just emphasized, we call it an octane. And then on carbon number 4, we are having what we call an ethyl group. So an ethyl group is CH2, CH3. So we go to carbon number 4, we write an ethyl group. So that will be our ethyl group, CH2, CH3. That will be our ethyl group because they're saying 4-ethyl. So it means to say on the fourth carbon, we're going to have an ethyl group. And then they told us again that it's 2,3 dimethyl. So on carbon number 2, we're going to have a methyl group, which is a methyl group. We know that that is CH3. So that is our methyl group on the second carbon atom. We're gonna also have, rather, let me write it like this so that I don't do mistakes. So it was correct, but I don't want everything to be congested. So I'm gonna draw it like that. That is our CH3 on the second carbon atom. Then on the third carbon atom, I'm gonna also draw an alkyl group called methyl group, right? So that's how basically you draw it. Then after that, it's a matter of you now making sure that each and every carbon atom has at least an hydrogen attached to it. There's at least an hydrogen attached to it. Just like that. So one thing that you need to understand is that you always look at the ethyl group for this structural formula. And then the ethyl group here, it will be represented by the radical. So that is the ethyl group. But we know that this ethyl group we categorize it as an alkyl group. So when they say an alkyl group, they can simply mean to say, tell us whether it's an ethyl or methyl or propyl or butyl, right? And then um, the one that we are having here with the blue color, it represents the methyl group. Even here, we're having what we call the methyl group, right? Having what we call the methyl group. So that will be the structural formula for ethyl 2,3 dimethyl octane. So if it's octane, it must have 8 carbon atoms, right? And then here they want us to draw the structural formula of 3-ethyl 2-methyl pentane. So since it's pentane, it must have 5 carbon atoms. 1, 2, 3, 4, 5. Then let's number it. 1, 2, 3, 4, 5. And then on carbon number 3, we are having what we call an ethyl group. So I'm just going to draw my ethyl group on carbon number 3. And the ethyl group, we know that that is CH2, CH3. So that will be my ethyl group. And it doesn't matter whether you draw the ethyl group underneath carbon number 3 or the ethyl group on top of carbon number 3. As long as it's CH2, CH3, it will tell you that that is an ethyl group, right? Then we're also having a methyl group on the second carbon atom. So the methyl group on the second carbon atom is CH3. I'm going to show it using a blue color right there, so that you can be able to understand that we're talking about a methyl group. And then here, add the carbon, we add the hydrogen, so to say we add the hydrogen, 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 yeah, hydrogen. So the tricky part is that you must understand that the red part represents an alkyl group, right? An alkyl group, and then that type of an alkyl group, we call it what? An ethyl group. And then an ethyl group, you must always remember that it will be what? CH2, CH3. CH2, CH3. So actually there was no need of me trying to elaborate this much more. I wanted you to basically understand, right? And then here, don't forget that this blue part, we call it an alkyl group as well. And then this alkyl group, it falls under what? We call it a methyl, right? So this is the structural formula: 3-ethyl, 2-methyl, pentane. If it's pentane, it must have 5 carbon atoms, right? Then this one is a bit advanced, it's a bit complex, but the moment you now understand all the structural formulas that I've just showed you before, then I think this should be easier to you. So they're saying draw the structural formula of 3,6 diethyl, 2,4,6 trimethyl octane. So in simple terms, it's an alkane that has 8 carbon atoms. Let's start there. 1, 2, 3, 4, 5, 6, 7, as well as 8. So that is an alkane with 8 carbon atoms. Why? Because it's an octane. And then let's now number it so that we don't do mistakes. So it's 1, 2, 3, 4, 5, 6, 7, 8, right? And then on carbon number 3 and 6, we're having an ethyl group. So let's start by drawing an ethyl group. So ethyl group is CH2, CH3. So that is going to be our ethyl group. And an ethyl group, remember, it's CH2, CH3. So the red part, I'm going to show the ethyl group. So on carbon number 3, as well as carbon number 6, we're going to have what we call an ethyl group. So there you go. CH2 as well as CH3. Right? We are done with this part of an ethyl group. And then on carbon number 2, 4, and 6, we're having a methyl group. So methyl group is CH3. On carbon number 2, we're having a methyl group. So that will be my methyl group that is there on carbon number 2. Then as well as on carbon number 4, we are also having a methyl group. So that will be the methyl group that we are having on carbon number 4, as well as carbon number 6. So carbon number 6, we're going to also have a methyl group. Don't forget that the methyl group is CH3. Just like that. So now let's double check. 3,6 diethyl. So on carbon number 3 and carbon number 6, we're having our ethyl group represented by red color. Correct? And then 2,4,6. So it's tri. Tri means 3. Ne? So it means to say on our structural formula, on carbon number 2, number 4, number 6, I must have 2, 4, and number 6, I must have a methyl group. So you can actually see that the methyl group is represented by a blue color. Yeah, correct. And then octane, it should have 8 carbon atoms. Then we are now cool to go. So it means to say now it's a matter of you adding the number of hydrogens on the spaces left, right there. So it's a matter of you now adding the number of hydrogens. Make sure that you draw it so that it's much neat, ne? So hydrogen there, hydrogen, hydrogen. I know that some of you'll be confused because you won't be knowing what are you working with. So the red part, it represents an ethyl group. So this is an ethyl group. It's an alkyl group called an ethyl group, even here. An ethyl group. And then the blue part, here we are having a methyl group or the methyl group. Even here we are having what we call the methyl group. Even there we are having what we call the methyl group. And then since it's an alkane that is having 8 carbon atoms, so an alkane with 8 carbon atoms, what do we call it? We call it octane. We call it octane. Do you get to see that? So that's how basically we show that. And then remember that this red part is an ethyl group. This red part It's an ethyl group, right? It's a branched ethyl group. Then this one, it's a methyl group. That one, it's a methyl group as well as that one. It's a methyl group. Then I think when it's like this, it now makes sense. So the moment you can know the first one, it will be much easy to know the second one. It will be much easy to go to the third one as well as this one. But this one, 3,6 diethyl, 2,4,6 trimethyloctane, it will be a bit difficult to you the moment you don't understand how to draw a basic structure of a structural formula of any given structural formula, whether it's an alkane, alkenol, or alkyl. Remember, it, practice makes perfect, right? It's a one and only favorite chemistry teacher. Subscribe and stay tuned for more.